per and polyfluoroalkyl substances and their increasing effect on health. What are PFAS? PFAS are a group of nearly 15,000 synthetic chemicals according to a chemical database, CompTox. Similar to human cells, PFAS are amphiphatic. This is due to their acid head, their oxygen-hydrogen head, and then their fluorine-carbon tails, which are very similar to the carbon-hydrogen tails present in amphiphatic human cells, which is a major reason as to why they're dangerous for the human body. It's because their structure is nearly identical to the amphiphatic cells present in the human cells. Now, you might wonder what they're used for. They're used in basically everything. We have weather-resistant clothing, paint, stains, and varnishes for woods, plastics, and stuff like that. Shampoos, nail polish. We have microwavable packaging, candy wrappers, packaging for basically every food on the planet. Any nonstick coatings such as Teflon, pesticides, and firefighting foams are all some of the big examples that we use in our everyday life. It's nearly impossible to escape how many things PFAS are in. And that's a major reason why we should be worried. Because they're common, it will and has contaminated so many water sources on this planet. They're really hard to remove without creating secondary waste, and they can have some really big, dangerous long-term effects. With individuals with higher baseline plasma PFA levels tending to gain more weight in a diet-induced weight loss trial, which means they don't really lose weight because higher PFA levels are also associated with slower regression of resting metabolic rate following weight loss, which means that even when they lose weight, it's hard for them to keep that weight down because of higher baseline PFA levels. And then PFAS are also accumulate in body tissues, especially the liver. And this has caused a prevalence of non-alcoholic fatty liver disease, NAFLD, rising quickly in the United States, which this rising cannot fully be explained by diet, lifestyle, or genetics. And this video by Veritasium, there's someone who takes blood, and it's known that around 98% of the population is contaminated with PFAS. However, as he will explain in the video, they don't really find anybody that isn't contaminated.
Been doing blood testing on PFAS since 2007, and I've never seen a non-detect.
No way.
So I hear that 98% of the population has PFAS in their blood, but I'm looking for that 2% that doesn't, because I've yet to see them.
That's incredible. I mean, very, very bad incredible, but wow.
But if everyone on Earth has trace amounts of these chemicals in their blood, how much harm could they really be doing?
I want to make a distinction because it turns out not all PFAS are equally dangerous. You can kind of split them up into two groups. First up, you have long, repeating chains of carbon-fluorine bonds that are tens or hundreds of thousands of atoms long. So stuff like Teflon. These are so big and inert that even if you do ingest them, your body's just going to flush them out. They can't be absorbed into your bloodstream, so you're pretty safe. They're called fluoropolymers because of the long, repeating chains of carbon and fluorine bonds. But the catch is, to make these fluoropolymers, stuff like Teflon, you need to use processing aids, things like PFOA or Gen X, and those are the nasty ones. These molecules are 5 to 10 carbons long, which makes them small enough to actually enter the bloodstream. They have functional groups at the ends that are usually acids. The most common ones are perfluoroalkyl acids, which means that they can bind to the proteins in your blood and be transported anywhere in the body. So they slowly accumulate and build up over time. Now, there are more than just two groups of PFAS and even different definitions of what PFAS even are, but most of what we know really relates to just a handful of chemicals from this group here, to these perfluoroalkyl acids.
Perhaps the most comprehensive document on PFAS toxicity was published in 2022 by the National Academies of Sciences, Engineering, and Medicine, and it looked at only 7 perfluoroalkyl acids. These are sister chemicals to PFOA, and some of them, like PFOS and PFHXS, were used heavily in the production of stain and water-resistant products, like 3M's Scotchgard, before they too got phased out due to toxicity concerns. The report surmised that if the sum of these 7 acids in your blood is below 2 parts per billion, there shouldn't be any harm. If your level is between 2 and 20 parts per billion, there's a potential for harmful health effects. Although the exact mechanism by which PFAS cause harm isn't fully understood, exposure has most consistently been associated with high cholesterol, a decreased immune system response to vaccines and infections, kidney cancer, and decreased growth in infants.
And if you want to learn more about DuPont and other studies based around PFAS and their sister chemicals, I heavily recommend watching this Veritasium video. And in that National Academies report, they found sufficient evidence of some of the things mentioned, such as the decreased antibody response for vaccines in adults and children, dyslipidemia, decreased infant and fetal growth, which is like small weights in fetuses at birth. Then you have increased risk of cancer as well, but basically only in adults because of the recency of studies. And they have limited suggestive evidence, which is possibility of chance of increased risk of breast cancer, liver enzyme alterations in adults and children, increased risk of pregnancy-induced hypertension, and increased risk of testicular cancer, thyroid disease and dysfunction, increased risk of ulcerative colitis. And then immune effects other than things mentioned above, other cancers, developmental outcomes other than reduced weight in fetuses, and musculoskeletal effects had little effect based on their studies from PFAS. And a reason why it's so important that we start educating about PFAS, start learning more about PFAS, is because of how massively incorporated they are into our water systems. With of mostly all of their 2,854 sites they surveyed in the United States and two territories, almost all of them had contamination, with a couple of them being military sites and other unknown sites. It's really hard to escape PFAS in our daily life, which is why we need to educate about them, because it is so incredibly hard to treat them. Because of how strong carbon fluorine bonds are, they're highly stable. This stability allows them to resist common degradation processes, such as hydrolysis, oxidation, and microbial breakdowns, which are commonly utilized in like wastewater treatment plants. But because they aren't treated in wastewater treatment plants, we have to use secondary methods that mostly rely on absorption methods, such as activated carbon, resins, or membranes. These secondary methods are hard because they create secondary waste that is difficult to manage, and we can't exactly burn it off because that just creates more PFAS that are not taken away because PFAS are only increasing. And yeah, um, because PFAS are so hard to treat and because they are prevalent in nearly every water source, it's important that we stay educated in their increased effect so we can hopefully eventually bring enough awareness to the topic that we can help enable the future degradation and eventual and hopeful treatment of PFAS in our daily life in order to improve our chances at living healthy. Thank you.